Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk a little bit about GUID partitions. As we said in some previous videos, the GUID partitions are kind of the new standard. And as a reminder, we're just getting started here with our dead analysis. We have acquired our images, and now we're getting ready to analyze them. So more about GUID partitions. Now, these are part of the UEFI system that's replacing the BIOS booting process. So you're probably familiar with the BIOS and having to make settings and change some settings in your BIOS. And there are some disadvantages to the BIOS. The BIOS is going to try to boot your computer in 16 and 32-bit mode, and you have this nice modern hardware, and it just can't take advantage of it, at least not while it's booting. So the whole idea of UEFI is that it's supposed to replace this. Now, when it comes to GUID partitions, it allows up to 128 partitions. So that's great. There's no more worrying about, I have 4, I need more than 4, I have to have an extended partition, and I have to do all this craziness. It's very simple. And as I said, it is the new standard. So all current 64-bit systems ship with this. You know, if you buy a new computer that's a 64-bit computer, which most of the computers you would buy today are, it will come with a GUID partition system installed. So what does it look like? Well, we start out with our good old friend, the MBR. And here there's a reason for this. We have this protective MBR at the start because we don't really know what's going to try to read this. You might have an old system that tries to read this drive, and you don't want it to overwrite your drive. So it will say this entire drive is one big partition, then it's normally a type EE, which your old computer will say, I don't know what that is, and it'll ignore it. The next block will have your primary GPT header, and then you will have your various entries. So if you have a 512 byte sector, you will have 4 entries per sector because each entry is 128 bytes. So this is repeated until we get to LBA 34. And that is where the actual partitions start. Now, another interesting thing is notice that we have a secondary GPT header in the very last block, and then we have a repeat of our partition table entries. So this gives us a nice backup. If you're familiar with some of the Windows file systems, such as FAT32, you know that there's a backup boot sector. Unfortunately, it is only 6 sectors away from the primary one. So if there is a defect in that area of the disk, it might lead to trouble, even though you have a backup. So the idea here is that you have the entire disk separating the primary from the backup. That way, there's a lot less chance of both of these failing at the same time. So each partition record starts out with a partition type, GUID, and these are from a set of predefined types. And then you have a unique partition GUID, and then an 8-byte value for the first LBA, then an 8-byte value or 64-bit value for the last LBA, 8 bytes worth of attributes, and then a partition name that can be up to 72 bytes long. Now this is normally stored in Unicode, so this gives you up to 36 characters. What about the attributes? Well, the attributes are grouped together in chunks. So the first bit 0, says this is a system partition. So if that bit is set, that means that the operating system must preserve this partition as it is. It cannot change it. If the second bit is set, that says this is an EFI firmware partition. So don't change it, but just plain old ignore it. If the third bit is set, that is the same thing as having hex 80 as the first byte in your master boot record. That's the way of saying this is a bootable partition. We have a whole bunch of reserve space. They should be zeros. And then at the top part, we have in bits 48 through 63 a type-specific bunch of attributes, which varies by the type. Now, in the case of Windows NTFS partitions, bit 60 is used to indicate read-only, 62 as hidden, and 63 means please do not auto-mount it. So how do we mount these on our Linux system? Well, it turns out pretty easily. So let me just show you my computer, being a somewhat modern computer, naturally has GUID partitions. So if I do an fdisk on my A drive, SDA, and print out my partitions, you'll see that in fact I have 7 partitions. I have a Windows recovery partition, an EFI system partition, a Microsoft Reserve partition, and then I have 2 Microsoft Basic Data partitions. And in the middle, between those 2 partitions, I have my Linux file system and also a swap partition. So how do you mount this? This is super simple. Just like the MBR case without an extended partition, if I want to do this by hand, I have the start. I take the start and I multiply that number by 512, and I give that as an offset to my mount command, and it's done. It's that easy. You know, in this case, I'm not going to mount these because they're not in an image file. As we've seen before, you can use fdisk on an image file just as easily as a physical device. And one last thing I wanted to show you in this video. I can use dd if equals dev sda. I won't give it an out file because I'm going to go to standard out. I'm going to give it a block size equal to 512. I'm going to give it a count of 1. And what this will do is it should print out 1 sector to standard out. I will pipe that to XXD. And sure enough, here is my first sector. And what's in there? This is my MBR. Notice I have a file type of EE. And it tells me, if I decode this, this is the entire partition. What about the next one? So I can give it the command to skip. And I'll say skip equals 1. So I will skip the first block. And now I will print the second block. Well, what's this? This is that GPT header, the primary one. If I skip another, so I say skip equals 2, this gives me my partition. So here's my first partition. And again, these are 128 bytes long. So it goes from here down to here. and you'll see what's the name? Basic data partition. Well, that's what we saw earlier. We can also see the attributes. The attributes are set. Recall from our presentation that bit 0, which when set has a value of 1, indicates a system partition. I look at my third partition. Here he is. Microsoft Reserve partition. And finally, in this sector, I have a basic data partition. This is continued into the next sector. So I can skip 3, and I should have 3 entries. Here's the first entry, the second entry, and the third entry. Now, of course, you could get all of this and put it into a file or redirect it to the screen, your choice. And you would just need to modify this command slightly. And instead of saying, I want to skip all of this, I can just say, I want to get the first 4. And that should give me everything that I want. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.